Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to just try to help you understand the path-dependent nature of work terms and how you calculate the work done by forces along a path. And this is just meant to be an introductory video. And what we're going to do is imagine we've got this object here, and it's acted on by these two forces. F1, 10 newtons to the right, F2, 15 newtons up. And we're going to imagine that this object moves along this path from 1 to 2 and then from 2 to 3. And what we're going to do is calculate the net work done on the object by these two forces. Now, a thing I'd like to consider for this, if you're watching this video, don't try to put a gravitational force on it. That's not the intention here. This is also not meant to be a complete free body. Under these two forces, this thing would be accelerating this way and wouldn't be moving along this path. So in reality, there must be other forces involved, but I want you to just completely ignore those. This is just a kind of a made-up conceptual example. We are only going to focus on these two forces and calculate the work done by these forces as this object moves along this path from 1 to 3. So first of all, now let's talk about from path 1 to 2. So remember, work is force times distance, and also remember that only forces in the direction of motion do work. So as this object moves along this path, this force is doing positive work because the force is in the direction of motion. And the amount of work done, so let's see, work 1 to 2, is going to be 10 newtons times this distance, 2 meters. And that, again, work is positive because the force is in the direction of motion. Now the work done by force 2 is 0 because force 2 is perpendicular to the movement of this object. So we work this out and we get 20 Newton meters, or in other words 20 joules, and that work term would be positive because the force is in the direction of motion. So this would represent the total work done from 1 to 2, with force 1 doing work but not force 2. Now let's chat about from 2 to 3 now. Right, so the work done from 2 to 3 on this object, and again, imagining these forces are constant, so this thing's moving this way. Force 1 no longer does any work because force 1 would now be perpendicular to the motion. But force 2 is upward and the displacement is upward, so force 2 would be doing work, and the amount it would do is the force, 15 newtons, times the distance, 1 meter. And we get 15 joules out of that. The total work done on this object by these two forces from 1 to 3 is, of course, the sum of the work from 1 to 2 plus the work from 2 to 3. So that's going to be 20 joules plus 15 joules, which is plus 35 joules. All right, so the point of this video is just a little bit about how to calculate work terms and to help you understand when work terms are 0 for a force. And as this object moves along this path, force 2 is doing no work because it makes a right angle to the motion. And then along this path, force 1 is not doing any work because it is making a right angle to the motion. So again, just meant to be kind of an introductory video on calculating the work done along a path. I hope that this helps. Have a great day.